Last class I talked about Newton's method. Do you still remember it? Okay. So this class I'm going to talk about another iterative method that's called the Jacobi's method. We know that Newton's method is an iterative method which can be used to solve a polynomial, and Jacobi's method is another iterative method which can be used to solve an equation system. Okay, let's start. And suppose that we are given a system of equations like this, and it has equations. And firstly, we have to do some change to these equations. Firstly, I use the first equation of this system that is like this. Okay, this is the first equation of the system. And firstly, I move these atoms to the right of the equation side, and then divide it by the a11, and then I can get an equation like this. That is b1 minus a12x2 minus a1 minus xn, and that is over a1. So this is the equation. I transfer this the first equation to this equation. So I repeat this operation, and I can get a equation like this one. And I call this equation is a rewriting equation. That all of these equations are get from this operation, right? And then guess I have initial guess to the solution of the system. I called it the assumption 0. And assumption 0 is the x1 0 to 0 and to the xn 0. This is one assumption of the solutions of this system. And then I substitute these values to the right side of these equations, and then I can get another assumption, and I call the assumption of this iteration is assumption 1. That is x1 n and x1 and xn1. Then I repeat the iteration, that is to use these values and substitute these values to the right side of this system, and then I have get the second assumption of this the solution of the system, and that is assumption 2, and it's x1 2 and x1 x2 2 and xn 2, and repeat this iteration, and then I can get a set of the assumptions of the solutions. That is, for example, that this xk equals to a set of the assumptions. That is x1k, x2k, and to the xnk. And here k equals to 1, 2, 3, and right. This is the set of the assumptions of the solutions. And now we have a problem that is whether is that the Jacobi's method is convergent. If the Jacobi's method is convergent, we can know that this set of assumptions of the solution can convert to the exact solution of this equation system. And now I can give you a theorem that is this. If the matrix A is diagonally dominant, then the Jacobi's method is convergent. And so what is the diagonally dominant? Now I can give you a matrix like this. Like this one, that is 5, 1, 1, 1, 2, 2, 3, 5. We can say that all the elements in the diagonal that is bigger than the other elements in its column. This is the diagonally dominant. And if I give you a matrix that is like 1, 2, 1, 5, 1, 1, 5, 1, 1, and we can say that the elements in the matrix in the diagonal is less than the other elements in its column. So this is not a matrix. This is not a diagonal dominant matrix. So if the A is a diagonally dominant matrix, the Jacobi's method is converted, and then our assumption can convert it to an exact value of the sum equation system. So now the Jacobi's method can be concluded in the following process. That is, firstly, we have to say whether the matrix is converted, is diagonally dominant, and to say whether the Jacobi's method is the Jacobi's method is converted. So, and then we have to give an initial value of the assumptions, and then write out the Jacobi's formula, and use Jacobi's formula to continue our iteration, and then we can get a set of assumptions of our equation system, and after several iterations, we can get assumptions that is very close to the exact value, of the solution of the equation system. And now, maybe it's a little difficult to understand. I can give you a method. Okay, firstly, I have to say we can see this equation system, and firstly we can write out the A matrix. Okay, that is 10 minus 2 minus 1 and minus 2, 10 minus 1 minus 1 minus 2, 5. And we can say that the elements in the diagonal is bigger than the other elements in its column. So this matrix is a diagonally dominant matrix. So yes, the Jacobi's method is convergent. And if the Jacobi's method is convergent, we can use our Jacobi's method to calculate the solutions, right? And so firstly we have to rewrite our equations and just select these operations, and we can get the Jacobi's iteration formula like this. And we know that the zero assumption of the solution is 0, 0, 0, and we use 0, 0, 0 to start our first iteration, and it's like this one, and we can get the first assumption of our solutions is 0.3 and 1.5 and 2, and then use the first assumption of the solutions to start our second iteration, and we can get our second assumption of the solutions is 0.8, 1.76, and 2.66. And then we continue our iteration, and after 9 iterations, we can get the assumptions are like this. And we know that our exact solution of the system is 1, 2, 3, so we can say that after 9 iterations, we can get assumption that is very close to our exact solution. So the next assumption of our solutions is the approximate solution of the equation system. And so this is the Jacobi's method. And in total, we can say that the Jacobi's method only needs 3 steps. The first step is to say whether our matrix is convergent, and to say whether our matrix is diagonally dominant, and to say whether our Jacobi's method is convergent. And then we have to rewrite our equations into an equation that likes the Jacobi's formula, and then we can give an initial value and just start our iteration. And after several iterations, we can get our approximate solution of the exact solution of this equation system. Okay, that's all. Any questions?
What do you mean by convergence? Jacobi's?
No, it's just Jacobi's method.
So you said diagonally dominant, right? Diagonally dominant is
yeah, so I use whether the matrix is dominant, is triangular dominant to say whether the Jacobi's method is converted. And we have many other methods to say whether the Jacobi's method is converted. I didn't say about that.
Yeah, what is diagonally dominant means the diagonal element should be greater than the sum of all the previous elements.
Yes, that means that you can see that elements in the diagonal that is bigger than the other elements. Oh, sorry, the absolute value of the other elements in this column. That is like this. That, yes, column.
Column, it's row.
You can see that here in this column, the 5 is bigger than 1, and the second column, the 2 is bigger than 1. So this is the triangle.
Another tree.
Final question.
Okay.
Yeah. So actually a very trivial thing. So Jacobi method.
Yeah.
About pronunciation. So did you actually refer to the? You know that is something like Hebrew name, yeah.
What?
So I think if you pronounce it in English, it should be Jacobi.
Jacobi.
No, I mean yeah, but it should be Jacobi because Jacobi is like Hebrew.
Yes.
name, so it's like,
I
just wonder if you actually check the original text and actually.
Yes, I checked the dictionary and it told me that it's Jacobi.
Yeah,
Jacobi.
Jacobi is like,
Yeah.
I think you know, yeah, Hebrew, right?
It's Hebrew, also Italian.
Also Italian? I don't know.
Yes,
Oh,
Jacobi is
Hebrew,
Italian.
yeah.
I only know.
This Jacobi was Italian.
Jacobi is Italian.